special cases here today. Okay, so when you have three different variables, which I do here, x, y, and z, and in that situation you have to have three different equations, otherwise you don't have enough information to solve. What I was recommending to you guys when we did this last week was I usually just like to just kind of number the equations so I can kind of keep track of stuff. But ultimately what you want to do is you want to take this from being three equations with three letters to two equations with two letters. So to do that, you're just going to pick any two lines. And for this one, I would recommend using elimination maybe. But just pick any two lines. You're going to eliminate one of the variables. Then you repeat that process with a different set of two lines from the system, but you do have to eliminate the same variable. Okay, so if you're looking at that system, does anybody have a variable they think they might want to go after to eliminate first, or what might be, can you tell? Some of them might be easier than others to get rid of. Would you look at X? Would you look at Y? Would you look at, and different, you can do it different ways, but does anybody just, anything jump out at you that would be easy to eliminate? Oh, it's Monday. Okay, what do you think? Okay, if I put lines 1 and 2 together, let's just say I start with that. If I put the first two lines together, so let me just ignore this one for a second. Would it be easy to eliminate one of the variables? Yeah, actually, this is a weird question. So, if you just, I'm literally just going to copy this to the side real quick. If you look at 1 and 2 here, actually, the way this is, all of these variables are actually opposites here. And this was equal to 5. Okay, so all of these are opposites. I don't have to manipulate anything. I don't have to multiply one of the lines or anything like that. I can literally just add them together. These cancel, these also cancel, these also cancel. So they actually all just add up to nothing. So I would have 0 over here. Now the numbers, you got to check this. So if I have 10 and 5, that adds up to 15. So if all those variables ended up canceling out, what do you think I would write down as my answer? No solution. That's not true, right? 0 is not equal to 15. That's not true. So that just means this system has no solution. And that can happen with a 3 by 3 just like it does with a 2 by 2. Okay, now just let's say for the sake of argument, just real quick, and if you don't want to write this down, you don't have to. But let's say you didn't, maybe you didn't pick the first two equations. Maybe you picked like the second and the third. Just, I'm going to show you that it's going to look the same. Okay, so let's say I picked the second and the third equation. So just ignore that first equation for a second. You got to pick a variable that you want to try to eliminate. So if I'm looking at that, I would maybe go, okay, I could eliminate x really easily by just multiplying that second line by 3, because we want to try to get opposites here. So I'm just going to multiply everybody in that second line by 3 real quick, and I'm just going to copy the third line. And you're going to see here, just in case you didn't use the first two, you're going to notice when I do that, they all end up eliminating again. And I get here, it's a little different looking because it's going to be 0 equals 13, but it's still not true. So if you had done maybe those two lines together, we'd chosen to go a different route. Even though we solve it differently, we could get the same answer. So that's why there wasn't a lot of space there, because there's just no solution for that system. So I'm pretty sure there's at least one question on the homework tonight that's going to end up like that. Okay, is anybody having a question so far? Okay. Now, the next one I have here, this one is a situation where not all the equations have all the variables. So the first two equations have x, y, and z, but this third equation just has x. All right, so I'm just going to number these here real quick. Okay, so there's a couple different ways that you could do this. Does anybody have a variable they might go after? There's a couple different strategies you could use. So I could put the first two together and probably pretty easily get rid of the x, or I could get rid of the z. It's up to you. I don't have y in the third equation, so you would not necessarily want to eliminate y. What do you guys think? What would you maybe go after to eliminate here? Okay, somebody pick two equations and tell me the variable you want to eliminate. It doesn't matter. We can all do something different, but let's just do one together. Just pick any two equations there and tell me what variable you want to get rid of. What do you think?
1 and 2.
And get rid of what variable?
Thanks.
Okay, let's do it. All right, if I pick 1 and 2 and I get rid of x, would you multiply either of the lines by anything to do that? Which one would you do? By? Yeah, and honestly, it doesn't matter. You could do it to either one, but let me just run a negative through the second equation. That'll make the x's opposites, right? Okay, so this is just one option. So I'm literally just going to copy down the first line. And the second line, what I'm going to do, I'm going to run a negative through all those terms. It's just going to change the sign in each one. That'll make our x's opposites, which is perfect because that'll allow us to eliminate. So then this will be negative 2y. This will be plus 2z. And then plus 12. Okay, when I do that, the x's are going to go. We're going to get negative 7y plus 3z equals 15. Okay, so whatever variable we got rid of, we chose to eliminate x. Okay, so this is very important. Whatever variable you eliminate, you have to do that same variable when you match up two different lines. Okay, now you can pick 1 and 3 or you can pick 2 and 3. It doesn't matter, but we have to eliminate the same variable. So just so we all have the same thing, do we want to do 1 and 3 or 2 and 3? Doesn't matter. Should we do two? Let's do 2 and 3. Okay, now if I do 2 and 3, so just ignore that top line for a second. If I have to eliminate x, because that's what I eliminated the first time. If I have to eliminate x, do I need to multiply one or maybe both of those lines by something to get rid of the x? By? He says the top, so like line 2 by 2, would that eliminate the x's? I would use negative 2. Okay, so I'm just going to run a negative 2 through that second line. So that would become negative 2x. Now, negative 2 times that 2y is going to be negative 4y. Be careful here, negative times a negative. So negative 2 times that negative 2z is going to be plus 4z. And then negative 2 times 12 is going to give you 24. Now, this is just my advice. You don't have to do this, but this last equation has a gap in it, right? There's no y. So what I do just to help line this up, I just put in place of the y, I'm just going to put plus 0y. 0 times y would just be 0. That would wipe it out, but it might make it a little easier to line up. And then you have plus 2z, that's equal to 6. And same thing, I'm just going to add the bottom line to the top line. That's going to get rid of your x's. Now, I just put that 0y in just to line this up. This would just be negative 4y plus 0, so it's just going to stay negative 4y. 4z and 2z is 6z's, and 24 and 6 is going to give us 30. So we had two equations with two variables. Now we have, or sorry, three equations with three variables. Now we have these two. Okay, now you don't have to rewrite it if you want to use the space differently, but I'm just going to put these together real quick. Now, I have negative 7y plus 3z, and I have negative 4y plus 6z equals 30. Okay. Ultimately, I'm trying to figure out all these variables. So, if this is my new system here, what would you maybe do to figure out either y or z? One of them might be a little easier here. Top one by negative 2. Okay, if you multiply this guy by negative 2, that's just going to make the z's opposites. So I'm just going to totally rewrite it. So I'm going to get negative 14y. Nope, I lied to you. Positive 14y minus 6z equals negative 30. I'm running a negative 2. I'm going to copy that other equation I had, which was negative 4y plus 6z. And then that's going to be equal to 30. Okay, now I also put this on here because I think this throws people off too. When I eliminate the z's there, right? One's positive, one's negative, so they're going to cancel each other out. With the y's, we're just going to add these up. So 14 plus a negative 4, or 14 minus 4, this is 10y. Now, excuse me, the 30 and negative 30, that actually adds up to 0, and sometimes people will get that and they think they made a mistake, but we didn't. What does y have to do to make that true? Or maybe I don't have a y value there. It's 0. I think people get really tripped up. You can have y be 0. If I divide both sides by 10, 0 divided by anything is just 0. That means the y coordinate of this point is going to be 0, and that's totally fine. Once you have that, wherever you want to go with it, just back up one step. I'm just going to back up right here and write it underneath. So I have negative 4y, but now we figured out y was 0, plus 6z equals 30. This would just be 0 plus 6z equals 30. So that 0 is not going to do anything. I'm just going to divide by 6. Z is going to then be 5. And I've got 2 of the 3 variables. Now, once you've got 2 of them, you got to back up to the original system to figure out the missing value, which we don't have x yet. I would actually just, let me see if I can get this on the page here. I would just back up right here. If I just need x, you can plug these into any one of these equations. I would just plug it in right there because I don't even need the y value for that third equation. I'm not going to be able to get this on the screen, so don't you recopy this, but I'm going to recopy that line. So the bottom line in that system was 2x plus 2z equals 6. I don't know x, but I do know z is supposed to be 5. So we're going to end off the screen, sorry. We're going to end up with, let's see, 2x plus 10, that's equal to 6. Move the 10, it's positive, so I'm just going to subtract it. And I get 2x would be equal to, what, negative 4? So then what's x? Negative 2, thank you. You guys are so sleepy. Okay, now if you guys just want to leave it, as long as you have all 3 variables, that's perfect. But I just want to remind you from Friday, you can write this, we call it an ordered triple. It is the x value, which is negative 2 for this problem, the y value, which is 0, and the z value, which is 5. Is anybody having a question? Okay, now we're going to try a couple more of these word problems. See if you guys can set these up. All right. Okay, now, remember, you have 3 variables. So you have to have 3 equations, otherwise you don't have enough information to set this up. Now this one's kind of tricky. So it's going to say, I'm going to use A, B, and C for my variables here. So this says we have a triangle, all right? Triangle ABC. All right. Now it says measure of angle A is twice the sum of the measures of B and C. What does the word sum mean to you? Adding, right? Okay, so anytime you see the word is, you can literally just translate that to an equal sign. Anytime you have an is, it's equals. Okay, so I'm going to say angle A, right? A is twice, what does twice mean to you? 2 times, right? Okay, so it's twice the sum of the measures of B and C. Can anybody raise your hand? Like, tell me how you would write that. Twice the sum of the measures of B and C. How could I write that as the rest of that equation? How would you write the sum of B and C? B plus C, right? Okay, what would I do with the 2? It's supposed to be twice that, so how would I represent that in the equation? We're just going to put 2 in front of it. I would put parentheses, though, because it says twice the sum of B and C. So B and C, I'm doing the sum in the parentheses there. Twice that, we're just putting the 2 in front of it. That's it. That's my equation. Okay, now, here's the next sentence. Says measure of angle B is, so remember, is just going to be an equal sign. So I'm going to say B equals, okay, and then this says 3 times the measure of angle C. How would I write 3 times the measure of angle C? 3C. You guys are so quiet. Oh my gosh. All right, now, Remember, I told you if we have three variables, which I do here, I have three equations. So from that information, it just says what's the measure of each angle. The only other thing it says in the problem is we're working with triangle ABC. Does anybody know where I'm going to get my third equation from? Think about triangles from geometry. Yes, okay, the three inside, do you guys remember this? The three inside angles of a triangle add up to 180. So angle A plus angle B plus angle C has to add up to 180 if we're working with a triangle. So I know it's not really spelled out in a sentence there, but the fact that you have a triangle, that's where I'm going to get that last equation. Now, this one, I would tell you, this would be really nicely set up to do substitution. So here's what I would do for this question. So I've got three equations, right? If you want to use substitution, I would substitute that 3C in place of the B. All right, so you just have to do it in both of the equations. So I have three equations with three variables. If I substitute this, that second equation I wrote down, into the other two, that'll leave us with two equations with the same two variables. All right, so that top line, if I substitute there, I'm just going to do 2, and it'd be 3C plus C, and I'm just going to simplify that a little bit. So this would be 2 times 4C. So ultimately, I could get that just to be A equals 8C. Okay, now I'm going to write this just right in here with it subbed in. So A, instead of B, you just sub in the 3C equals 180 here. Just going to combine my like terms. So I've got A plus 4C equals 180. All right, so we went from three equations with three different letters to now I just have these two that I put in my lovely red pen. All right, if these are your two equations, does anybody know what you might do next to figure out the solution to that system? Perfect. Yeah, I would just substitute again. Just substitute this right here. You have 8C plus 4C equals 180. Now I had 3 with 3 variables, then I went to 2 with 2 variables. Now I have one equation with one variable that I can solve for. So this can be 12C equals 180. Now this would be the measure of angle C. Anybody know what that is? I think that's a nice number. 15. Okay. Okay. Now, depends on the question, but I would tell you here, if I was plugging this back in to find these other variables, here's where I would plug them in. So I would plug it in right here to get A, because I just have to multiply it by 8. And I would go back to my original problem here, and I'd plug it in right there to get B. So angle B, sorry, my pen just stopped. Angle B is just 3 times C, which would be 3 times 15, which, thank you, 45. Sad that I did not know that off the top of my head. Okay, and then the other one to get A, it would just be, what'd you get? I don't think it's 90. It's got to be bigger than that, so it'll add up to 180. Is it 120? I think it's 120. Somebody can check on their calculator if you want to, but I'm pretty sure that's right. And if you add them up, they should add up to 180. Yeah, I think these are right. Okay, so A would be 120, B would be 45, C would be 15, and I have my 3 angle measures. Does anybody have a question? Okay, I got one more, also kind of weird. And this is probably not like a normal scenario. Okay, anyway, it says Anna, Bob, and Chris are in 5th grade. They don't know how much they weigh. Anna and Bob together. So if I weigh them together, I'm going to add their 2 weights. So I'm just going to let A be Anna and B represent Bob. So if we weigh these 2 people together, these are 5th graders, this is 226. Okay, then it says Bob and Chris. So I'm going to do B and C together, weigh 210. And then Anna and Chris, so I'm going to say A and C together, weigh 200. Okay, now this is actually kind of a weird system because I do have 3 equations and 3 variables, so we can solve this. But none of the equations have all 3 variables, but you can still do this. Okay, anybody have any idea? You could use substitution or elimination here, either one. Let me just put numbers next to these. So there's my first equation, there's my second equation, there's my third equation. Okay, pick any two equations and tell me what variable you want to get rid of. What? 1 and 3. Okay, he wants to do 1 and 3. What variable do we have to get rid of then? A. Okay, so if we put 1 and 3 together, I'm just going to copy 1 really quick. Now 3, I'm just going to run a little negative through it, so those A's will be opposites. Now this is kind of weird, so it would be negative A. I don't have a B. And then I have a C. Sorry, I should have spaced that out a little bit better. Okay, now if I add these up, we're going to eliminate A, right? So this goes. Now, I'd have 1B, plus I don't have a B in the other one, so I would still have a B. I don't have a C in the top. Sorry, I should have spaced that out a little bit better. But I do have a C in the second equation. So if I was going to add them together and fail, I should have had a negative on that 200. Okay, now, if I do 226, negative 200, this would just be 26. So here's what I want you to notice. Do you remember which equation we did not use? 2. Okay, well check this out, because now these have the same variables, so you don't have to create another situation. What I'm just going to do here is I'm just going to multiply this equation by a negative 1. Just multiply that. That'll allow you, hang on a second, what did I just do wrong? We shouldn't be able to eliminate both. Oh, this is why. This should have been a negative. This should have been a negative. I'm so sorry, guys. I didn't run that negative through this one. This should have been negative C. My fault. Okay, so that should be B minus C. I am still going to run a negative through this. No, I don't need to run a negative through it now. I can just copy it. I can just do B plus C equals 210. My fault. I forgot to carry that negative through on line 3. Now, when you do this, you're just going to get 2b. These guys are actually going to be gone, and this is going to be 236. Once you're there, just divide by 2, and that'll give you Bob's weight, which is going to be 118. Oh, I'm not on the screen, sorry. Now, once you're there, just plug it back in. Okay, so Bob is in that first equation also. So Bob and Anna weigh up to 226. So if I just take the 226 minus Bob, Anna's going to be 108. And if I know Anna and Chris together weigh 200, I could just do 200 minus the 108. And Chris is going to be 92. So then I have the weight of each one of those people. So it's not, the hardest part I think is setting these up. Once you do that, there's a lot of different ways you can do these problems, but hopefully we're going to all end up with the same answer. Okay. Is anybody having a question?